Welcome to Perfect Classes. In this video, I will discuss about computer organization and architecture. Some important concepts. First is instruction set of architecture of a CPU. Second, interpretation instructions, instruction set. Then character representation, computer arithmetic, integer addition and subtraction, throughput and speed up. Pipeline hazards, memory interleaving and concept of hierarchical memory. And I will also discuss some other concepts after that. First point is instruction set of architecture of a CPU. What is the instruction set of architecture of a CPU? Instruction set architecture of a CPU is a crucial concept, is a very important concept which is used in computer architecture, and it also defines the part of processor. What will be defined? It defines the part of processor which is visible to the programmer, which is visible to the programmer, which is seen to the programmer, compiler, writer, and instruction set of architecture also serves as an interface between the hardware and software, and it also describes how a processor handles instructions, memory, input, output, and data. This is called a instruction set of architecture of a CPU. We can say that instruction set architecture ऑफ ए सी पी यू एक बहुत इंपॉर्टेंट कॉन्सेप्ट है कंप्यूटर आर्किटेक्चर के अंदर, जो कि प्रोसेसर के पार्ट को डिफाइन करता है कि कैसे एक प्रोग्रामर को वो विजिबल होता है, कैसे कंपाइलर राइटर को विजिबल होता है, और वो एक इंटरफेस की तरह काम करता है हार्डवेयर सॉफ्टवेयर के बीच में, कैसे एक प्रोसेसर जो इंस्ट्रक्शन, मेमोरी, इनपुट, आउटपुट और डेटा को हैंडल करता है. सेकेंड टाइप इज इंस्ट्रक्शन सेट. It defines the complete list of instructions which CPU can execute, and each instruction perform a specific operation like arithmetic, logic, data movement, control or input output. And what are the types of instructions? There are different types of instructions are given: data movements, arithmetic, logical, control flow, input output instructions, special instructions. Data movement means we will use in this mob instruction, LOD load, store store. मतलब it means move means we if we want to move from one file to another file, then we will use mob instruction set. If we want to load any file, that is no then we use instruction set LOAD, and if we want to store any information in a file, then we use STORE instruction set according to data movement. Arithmetic. In arithmetic we will use add for addition, SUB for subtraction, MUL for multiplication, DIV for division. In logical and or not XOR, these instruction sets are used, and in control flow we will use JMP, CALL, RET, BRANCH, branch, LOOP, loop. In input output instruction we will use in or out. Special instruction NOP, HLT, interrupt handling, all these are the types of instructions which are used in the instruction set. Now next is instruction format. Instruction format specify how bits are arranged in an instruction word. And instruction format typically include OP code, operands, addressing mode bits, etc. OP code means operation code, what action to be performed: addition, subtraction, multiplication, division, etc. Operand means register or memory location where we store the variable. Addressing mode bits means it specify how to interpret the operands. And for example, OP code 6 bits, source register 5 bits, destination register is 5 bits, and immediate or data register is 16 bits. These are the example of some instruction formats. Now next is what is addressing mode. These define how the operand of an instruction is chosen. First is immediate. Immediate means operand is a part of instruction. Means MOB move R1. R1 is the register that is move, and in which hash 5 is the number. And register operand is in a register, and add r1 comma r2 means r2 register is add in r1. Direct memory address is specified directly. Indirect means a register contains memory address of some other register. Index base plus index offset, which is used in array. And relative, it is used for branching and jumping purpose. This is called the these are the addressing mode which are used in the computer's organization architecture. Next is registers, small fast storage, which is inside the CPU, which is used to store the immediate data and operands. And some common registers include like general purpose register, special purpose register. In general purpose registers, we will use, for example, R0 to Rn registers. And in special purpose register like program counter, instruction register, stake pointer, status register, or flags, etc. In program counter, we points the next instruction, and in instruction register we holds the construction current instruction. In stack pointer we points to the top of the stack, and in status register or flags we hold the condition codes like 0, carry, sign, and overflow, etc. Now next is data types supported. It defines the types of data which supports the CPU, which can process the CPU like integers, floating point numbers, character, boolean, vector, etc. In SIMD architectures. In integer we can take only without decimal numbers. In floating point we can take the decimal numbers. In characters we can take in single characters or a group of characters. In boolean true or false. In vectors in the form of matrix. Now next is the instruction execution cycle. This is how the CPU processes instruction. This tells how CPU processes the instruction. Means first of all it fetch the data, means it get the instruction from the memory, and then it decode the data, means it decode the fetched information instructions, then execute. It performs the operation plus minus multiplication division etc, which is given by instruction CPU. And after that memory access. If needed access memory read or write, then we will use these instructions, and after that write results to the register or memory, and then update the PC and move to the next instructions. These are the main basic instruction execution cycles, and this question is very important for exam point of view, so you should be learn it properly. And what is the instruction interrupts and exception mechanism which handles the external events or internal faults. That interrupts and exception means it is that mechanism which handles external events or internal faults. And in this CPU must support the interrupt vector table and it modes for the handling them. And next point is modes of operations. There are different types of privileges levels, like user mode and kernel or supervisor mode. And user mode is limited access mode, and kernel supervisor mode is full access to hardware and resources mode. Now next is the interpretation instructions. Instruction interpretation is the process by which a CPU understand and execute a binary machine code instruction, that is 0101 instruction. This happens during the instruction cycle, particular decode or execute phases. And instruction cycle overview. The CPU follows these basic steps to interpret and act on the instructions, like the fetch. Fetch means you have to retrieve the instructions from the memory which pointed to the program counter PC. Second is decode. Interpret the instructions. Interpret the instructions binary code to determine what actions to be performed and execute. It performs the required actions, arithmetic, data movements, control flow, etc. Memory access. If needed access memory operands, write back, save the results to a register or memory. Update means In the last it moves to the next instruction. Here also we discuss about the instruction life cycle. And next is the instruction decode phase, core of interpretation. For example, you have given in binary form these instructions, 101 4 times 01, then 6 times 010. And here we assume this is a 16 bit instruction on a simple architecture, here how it is interpreted. In this case 8 bits are 8 bits are used for op code, that is operation code, and value is 101 4 times 01. And this values means move instruction mob. And these are the 8 bits which is used for the operand register, and that these values are for 6 times 010, that means register 2 R2. And now next is steps. What are the steps which are used in the control unit? First of all, you have to in this control unit takes the operation code 101 4 times 01, and then it decodes. Means in previous questions, example which is given, I have given example in the binary form how to work this binary example, and what steps will take CPU for this, and for we will discuss these points. First of all, CPU in CPU control unit takes the operation code, and then after that decode it, and then identify which instructions is given, and it identify that here given is move move data. And after that it decodes these bits, or these are the operand bits which tells the operation involves the register R2. And after that, based on this, the control unit trigger signals to they perform a move operations from or to register to. What are the role of control unit in interpretation? Control unit which plays the very important role in interpreting instruction. It decodes the binary op code. First it decodes the binary op code, after that generates the control signal which activates the correct data path and ALU function or memory accesses. After that coordinates the data flow between the CPU units and register ALU and memory. And it also often uses micro instructions which are given in a microprogrammed CPUs and hardwired logic in RISC CPUs to do this. And next is a micro operation triggered by an instruction. What do you mean by this? By micro operation triggered by an instruction means, for example, uh, you have given add r1 comma r2. It here r1 comma r2 means r2 register is added in r1 register. Means in given r2 value 5, and in r1 register given 3 value, 5 is added in 3, that is equal to 8. How these steps will be execute in the CPU in a COA? First in interpretation trigger, first of all it fetch the operands, these are r1 and r2 from R1 and R2 register. After that it implement ALU operation, that is plus operation. It performs R1 plus R2, that is equal to 8. After that it stores the result in a destination register, that is known as R1, because the first return R1 and second return R2. R2 is a source and R1 is a destination register. After that update the flags, zero carry overflow. If the after adding the number, if any value carry, then it will carry. If any value overflow, then it will be show the overflow, and after it will no carry or overflow, that means it will be 0. And next is instruction formats and interpretations. Different formats which helps the CPU understand how many operands exist, whether operands are immediate, register, memory addresses, what operation is common formats. R type, that is known as a register, which is used for ALU operations. I type, that is immediate, which is used when operand is constant, and J type, which is used that is known as jump, and which is used for control flow, and each format has a specific bit fields and interpreted accordingly. Now next is examples of instruction interpretation. For example, you have given load r1 comma 0 x 0040. Here op code decoded as a load, and addressing mode is direct. Load data from memory address, that is 0x0040 into register 1. And second example, add r3 comma r1 comma r2, that means here op code decoded as a add, and controls unit reads r1 and r2 as a value, and ALU compute r1 plus r2. After that, result is stored in r3 register. This is the example of instruction in interpretation in risk and versus syscom. Decode in a risk, simple fixed length in the length is for the decoding. In CISC, it is a complex variable length. Execution one instruction is equal to one cycle, and in CISC it may be take multiple cycles. Instruction set in a risk, small and regular interpretation, but in CISC it is large and irregular. These points should be keep in mind when we write about the interpretation. And the next point is character representations. How to character represent? Characters are represented in computer by using the binary code 01 01, and through the character encoding schemes like ASCII or Unicode, and Unicode is used. Each character is assigned a unique numeric code, and which is stored in a binary form. In ASCII, the letter A is represented by binary 0, 1, 4, 5 times 6, 5 times 0, 0, 1. This is a represent to A character. And next is computer arithmetic integer and integer addition and subtraction. Integer addition and subtraction in computers are performed by using binary numbers, and the CPU uses binary arithmetic, handles both positive and negative integers, and it also often using 2's complement representation. In binary addition, rule is 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1, 1 plus 1, sum is 0 and carry will be 1. In binary subtraction, handled using 2's complement. First, subtract b from a and add a 2's complement of b. First of all, invert the b 1's complement, then add 1, that is 2's complement, add to a. Means, for example, we have given like 1 0 1 1 0. This is A's value, and we have to implement 2's complement. But before going to 2's implementing 2's complement implementing, first we have to implement 1's complement, and 1's complement means we have to convert 0 to 1, 1 to 0. That means here value will be changed 0 1 0 0 1. Now we will add 1, and when we add 1 we will find 2's complement like this: 1 1 0 1 carry according to this rule, and after that 0 1 0. This answer is 2's complement. Computer perform integer addition and subtraction using binary arithmetic with 2's complement used for handling negative numbers. You should be keep in mind. Next is a throughput. Number of tasks or instructions a system can complete in a given amount of time. Means ki in computer there are number of tasks, there are number of instructions which are given by CPU that will be complete in a given amount of time, and that time is known as throughput. Total task which is completed and divided by total time taken for that task completion, that is known as a throughput. If a processor complete 100 instructions in a 10 second, then we say that 100 divided by 10, that is 10 instructions per second. that is known as throughput. But is a speed up a measure of how much faster a task runs on an improved system like a faster CPU or parallel setup. Speed up means we will be find it by this formula old execution time divided by new execution time, and we will find out speed up. If a task take the 10 seconds in one system and 5 seconds in another system, then we can say its speed of time is old time is 10 second and new time is 5 second, and you can say this is a second two multiple faster speed up. Now next is a throughput. Means throughput measure the task completion rate and speed up measure the performance improvement between systems. Now next is a pipeline hazards. The pipeline hazards are the problems. Pipeline hazards are problems that prevent next instruction in instruction pipeline. Means pipeline are those problems which prevent next instruction, which stops the next instruction in instruction pipeline from executing its in its designated clock cycle. They reduce the efficiency of pipelining. And what are the types of pipeline hazards? Structural hazard, it occurs when hardware resources are insufficient. Means two instructions need the same memory or ALU. Example, both instruction fetch and data access need memory at the same time, that is known as structural hazard. Data hazard occur when instruction depend on the results of previous instruction. For example, add r1 comma r2 comma r3. Here r2 and r3 two values which are added and which are stored in r1 register. After that, subtraction r4 comma r1 comma r5. Here r1 not ready yet. This is a data hazard. Control hazard means branch hazard. It happens due to branching or jump instructions which change the flow of execution, like go to, break, and continues, some jumping statements. When we use that control the hazards. For example, uncertainty about which instruction to fetch after a conditional branch. Pipeline hazard slow down the instruction execution. It slows down the execution instruction execution, and it must be managed using some techniques like stalling, forwarding, and branch prediction, etc. Now, what is a memory interleaving? Memory interleaving is a such type of technique which is used to increase the speed of memory access by dividing memory into multiple modules and accessing them in a parallel. And how it works? It The memory is split into modules. Means memory is divided into modules: module 0, module 1, module 2, etc. And consecutive memory addresses which are distributed across modules. And while one module is accessed, then others can prepare for next access, and it reducing the waiting time. And types of interleaving means low order interleaving and high order interleaving. In low order interleaving means it uses lower address bits to select memory modules, and high order interleaving means it uses higher address bits. Address 0, that is module 0. Address 1, module 1. Address 2, module 2. Address 3, module 3. Address 4, that is module 0. It wraps around. And memory interleaving improves the performance, which allowing parallel access to memory modules. It also reducing memory access time, and it also increasing throughput. Now, next topic is concept of hierarchical memory. This is a concept of hierarchical memory. Hierarchical memory refers to organization of memory, computer memory in multiple levels which are based on the speed, cost, size which is achieve high performance at a low cost. Now, first level is one top where we use registers. The registers are fastest, most expensive, and smallest size. Level 2 cache memory. L1, L2 that is very fast and high cost and very small as compared to registers. Level 3 is main memory that is known as RAM, which is moderate cost and medium size. Level 4 that is secondary storage, in which we use HDD, SSD, which is its speed very slow, its cost very low, and its size is large as compared to register, cache, and main memory. Level 5 that is the bottom level, and that is the territory storage, and for example tape, which is very lowest speed, and its cost very low, and its size is also very large. Now next topic is next point is about the hierarchical memory. First is point is frequently used data which is kept in faster, smaller memory like cache. Less frequently used data which is stored in slower, larger memory that is known as hard drives, and the system automatically which moves the data between levels to optimize performance. Hierarchical memory provides a balance between speed and cost by how it organizing memory into different levels, and it also ensure the fast access to critical data while using slower cheaper storage for the bulk data. It means hierarchical memory which provides balance between speed, cost, and which is organizing by organizing memory into different levels, and it also ensure how to fast access to critical data when we using slower cheaper storage for bulk data. Bulk means large data. Now next is a what is a virtual memory. What is a virtual memory, and how what are the steps involved in memory address translation? Virtual memory is that memory management technique which gives an application illusions of having a large continuous block of memory, even though actual physical memory like RAM, which may be smaller or fragmented, but it allows the program how to use more memory than in physically available memory by temporarily transferring data or to or from disk, usually a swap file or paging file, that is known as virtual memory. What are the features of virtual memory? It's isolation, it's efficient memory use, it provides security, it is a convenience. Isolation means each process gets its own virtual address space. Efficient memory use means not all of a program it needs to be in a RAM at once. Security means memory access violation are easier to detect and prevent. Convenience means it enables the large application how to run on the limited physical memory. Steps involved in the memory address translation means when a program access memory, it uses virtual addresses, and CPU must translate these into physical address to access the RAM, and this process involves many steps. First, the CPU generates a virtual addresses. Each running program which uses virtual address, when CPU access the memory, then it first of all fetch an instruction, then load the data, and it sends to a virtual address. Then it sends to virtual address. How to CPU generate virtual address? First of all, it see each running program which using virtual addresses. When CPU access memory, means it fetch an instruction or load the data, then it sends the virtual address. Now next is a check the TLB, translation look aside buffer. After that it check the TLB, that is translation look aside buffer. TLB is a small fast cache in CPU which stores the recent virtual to physical address translation. And after that, if virtual address is found in TLB, that is called a TLB hit, means translation look aside buffer hit. Translation is fast. If TLB miss, if you do not find virtual address in the TLB, that means TLB is miss and system must do a page table lookup. And what is a page table lookup? The page table is a data structure which is used by operating system to store the mapping between virtual page number and physical frame number. Virtual page number is the part of virtual address and physical frame number is the part of physical address. You should be keep in mind these 2 points. Virtual page number is the part of virtual address and physical frame number is the part of physical address. Steps. First of all, it extracts the virtual page number from virtual address. Then it use it to index into page table. After that it get the corresponding physical frame number and then it combine physical frame number with offset from the virtual address to make a full physical address. After that, how handle page fault if needed. If page is not present in RAM, then valid bit in the page table is 0 and a page fault occur and operating system suspends the program, then load the required page from disk into a free frame in the RAM. After that it updates the page table with the new mapping and then it resume the execution. Now next is a access physical memory. Once the translation is complete, these are also parts of the virtual memory. Once the translation is complete, then CPU accesses the correct location in physical memory by using physical address. After that, translation can also be stored back in the translation look aside buffer and to speed up the future access. For example of address translation simplified. First of all, we assume address virtual address is 0x3f24. Then we the see page size that is 4 kb is given, offset is 12 bits and virtual address then breakdown of virtual page number upper bits 0x3 it 0x3 f24. These are the upper bits that is known as virtual page number and and 0x f24 that is the lower bits 12 bits that is offset. And after that step first is extract bpn 0x3, then page table lookup in which we see bpn 0x3 which represent to physical frame number 0x7. After that combine physical frame number and offset means pfn 0x7 physical frame base 0x7 000 offset 0xf24 and physical address is now physical address will be 0x7000 plus 0xf24 and when we combine it 0x7524 will be get. How it will be get 0x7000 and we will add f24 0x, then we will get f24 f and when we solve it this is 0x7 f24. And protection and permissions. The page table also include metadata. Valid or invalid bit is the page in memory and it also read, write or execute the permissions. Now next topic is mapping techniques. Mapping techniques define how virtual addresses are translated to physical address in a memory system and especially in a cache memory and virtual memory. There are common mapping techniques. First is a direct mapping. In a direct mapping, each block of main memory maps to the exactly one cache line and simple and fast, but can cause many conflicts, cache misses. Second is a fully associate mapping. In fully associate mapping, any block of main memory which can be placed in any cache line. And second, flexible with fewer conflicts but requires complex hardware for searching. And set associative mapping means cache is divided into sets. Each memory block maps to a particular set. Each memory block which maps to a particular set but can be placed in any line within that set. Balances complexity and performances. And mapping techniques control how data is placed and found in memory or cache, and it also impacting what is the speed and what is the efficiency of memory access. Now next is a parallel process. A parallel process refers to the simultaneous execution of multiple instructions or tasks which by dividing them into across multiple processors or cores to the improve performance. What are the types using for parallel process? First is a bit level parallelism. That means multiple bits processed simultaneously. Instruction level parallelism means when multiple instruction executed at once, that is known as pipelining superscalar. And data level parallelism means the same operation on multiple data elements are executing. Task level parallelism means different types of tasks, different types of processes which run concurrently, multi-processing, that is not task level parallelism. And in what are the benefits from parallel processes? Its computation very fast, and it improves the throughput. It provides the better resource utilization. These are the benefits. Now next is a pipeline. What are the peripheral devices and their characteristics? Peripheral devices are those devices which are external or internal hardware component and which are connected to a computer to input, output or store through the cable. Now next point is what are the types, the device types? Input device, example keyboard, mouse, scanners. These are the peripheral devices which allow the users how to send data to computer. And output devices, in these are the monitor, printer, speakers are peripheral devices which presents the data from computer to user. And storage devices include hard drive, USB drive, CD, DVD, etc., which stores the data permanently or temporarily also. Now next is what is a ripple. Ripple usually refers to behavior in certain digital circuits, which is especially in ripple carry adder used for the binary addition. When we use carry 1 plus 1 0 and carry 1 carry, this is called the ripple carry adder, and a type of binary adder where carry output of each bit is passed to next higher bit. Each full adder each full adder waits for the carry from previous one. This creates a ripple effect. Why called ripple? The carry bit ripples through the adder chain from least significant bit to the most significant bit. And this causes delay, making it slower for large bit width addition. Characteristics mean what are the characteristics of this? It is simple to design. It's slow carry propagations due to the sequential dependency. It delay is proportional to the number of bits. 4-bit adder has 4 stages of delay. Ripple in a computer organization architecture refers to sequential carry propagation in ripple carry adder, causing a delay as the carry ripples through the each bit position. Now next is a floating point. A floating point representation is a method which is used in the computer how to represent real number, how to represent decimal numbers, which including fraction, very large or small values in a similar to scientific notation. Format is I according to IEEE 754 standard. For 32-bit single precision sign, 1 bit exponent 8 bits maintains or fraction is 23 bits. Sign bits 0 it means positive, 1 means negative, exponent e which stores the biased form from 127 y is equal to 127 for 32 bits, and maintains which stores the significant digits normalized with the leading one hidden. And this is the formula which is used in floating point. That is just this is a formula. Value is equal to minus 1 raised to power s. This is used for sign bit, and 1 multiply m. This is used for maintenance, and 2 multiply x e minus y sum. That is used for exponent. Okay, these this is the binary form digits are given for example. And in this 0 sign which is represent to positive, exponent is 129, 129 minus 127, and it will be 2, and maintenance that is equal to 1.01, 1.25. When we convert binary to decimal number, that result will be 1.25 multiplied 2 raised to power 2 equal to 5.0. Here 1 is used for sign bit, and 25 is used for the maintenance. 0.25 is maintenance, and 2 raised to power 2, that means exponent form. And when we solve it, it will be 5.0 is the answer. What are the addressing modes and its types? Addressing modes define how the operand data of an instruction is accessed in computer memory or registered, and they are very important in instruction execution and effective program control. First is immediate. What will be the use of addressing mode of immediate? Immediate use for operand in which operand is directly specified in the instruction set. Like move r1 comma hash 5. Hash 5 is directly specified operand which is register move in the r1 register. And register operands is in a register. First operand goes into register, means r2 value goes into r1 register, add in r1 register. Direct instruction gives the memory address of the operand. In this like value 1000 is the instruction which is load into r1 register. In indirect address of operand is stored in a register or memory location, means r2's address of r2 is stored in r1 load in r1 register. Indexed means effective address, that will be equal to base plus index, and used in array access, like load r1 1000 r2 address 1000 is the r2's address, and it load into r1 register. And relative means address is relative to current program counter pc, which is used in branching. JMP, that is a label. Base register, this is similar to indirect but uses a base register, like load r10 rb, this is a base register. If you want to detail video of this topic, then you can say in WhatsApp or in mail. I will upload its detailed video, because it is not a short topic, it is very large topic. In It's very important topic, addressing mode and its types. Now next is a shift and add both multiplication. Shift and add multiplication is a method which is used in computer architecture to multiply two binary numbers using shifting and addition, mimicking the manual multiplication process. Basic idea: to multiply two binary number, add the multiplicand and to the result only when the current bit of multiplier is 1, and shift the multiplicand left multiply 2 for each next bit. Shift the multiplier right divide by 2 to example next bit. And then steps for unsigned binary multiplication: initialize the result to 0, check the LSB, least significant bit of the multiplier, and if it is 1, then add the multiplicand to do the result 1 and left shift multiplicand. For example, we have given a multiplier, we have given in example multiplicand a is equal to 0 1 1 multiplier 0 1 0 1, and result will be 4 times 0. How? Step 1, first of all, b in b0 equal to 1, r is equal to r plus a. In r plus a, we have to first add r plus a. 4 times 0 plus 0 0 1, we will get this number. After that, a 0 1 1 0, we have to shift, left shift, we will left shift like this. 0 0 1 1, we have to left shift left. It means this will come here and this will come here. 0 1 1, and here 0 shift behind this number, so you will get a left shift. And after that, 0 0 0, sorry, then right shift 0 1 1 0. How you can say right shift? This is the left shift. Now again to 0 0 1 1, it's right shift. This number shift here, this number shift here, this number shift here, this number shift here. Okay, and you can see here this will finish, and here will be, you will get 0 0 1 0. Okay, because in place of this we will add here 0. After, okay, we have to implement right shift on the b's value. 0 1 0 1, this shift here, and this shift here, this shift here, this shift here, and this will be cut here, and in place of shifting 1, we will place here 0 instead of this 1, and so we will get 0 1 0. This is the right shift. Means implement in on multiplicand left shift, and implement on multiplier right shift. After that, step 2, no addition, and after that you can see here, again implement this 1 1 0 0. You will see here, again implement left shift and right shift, you will get this. Step 3, now we will add 0 0 1 1 and 1 1 0 0. We will add these numbers and we will get a's value overflow ignored, and b's value to 4 times 0, that stop. Final result will be this, and at this will be 15. And shift and add multiplication uses binary shifting and conditional addition to compute product of two numbers and efficiently in digit circuits. You can see 1 0 0 0, this is the right shift, and this is the left 1 1 0 0. This is in step 2, and in step 3, we will take original value, that is 0 0 1 1, and its left shift value, and add them. 0 0 1 1 original value, and after left shifting, after 2 steps, then we will get a new number, that is add 1 1 1 1. This is your step 3's number. And in a, when we shift, Now a, you can see if we shift 1 and if we add 1, 0 0 0 0 1 is overflow. And now if we deduct this, cut this number, you will see 0 0 0, this is now stop, and you will finally result will be find. Now explain DMA controller. A DMA controller is direct memory access controller, which is a hardware device that allow the peripherals like hard drives, sound card, etc. how to transfer data directly to or from main memory without involving CPU, increasing overall system efficiency. Why DMA is needed? Without DMA, CPU must copy data between memory and input output, which is slow and inefficient. With DMA, controller handles the transfer. Its CPU is free for other tasks. Working of DMA steps, peripheral device like disk, it requests the data transfer. DMA controller receives the request and gets the permission from CPU by bus arbitration, and DMA controller takes the control. DMA controller takes the control of the system bus. Data is transferred directly between input output devices and memory. Once done, then DMA controller sends interrupt to notify the CPU. For example, disk to memory transfer. Suppose a hard disk wants to transfer a file to RAM. Instead of CPU reading each byte and writing to memory, it will transfer disk from DMA transfer, then RAM direct transfer. Now next is a mode. Worst mode, DMA takes full control and transfer into blocks. In cycle stealing, DMA transfers one word at a time and by stealing CPU cycle. Transparent mode, DMA transfer data only when CPU is idle. Mapping function determine how blocks of main memory are mapped into cache memory in the cache memory system, and this affects the cache performance, hit ratio, rate and complexity. What types of mapping functions are used? Direct mapping, each memory block maps to the exactly one cache line. Formula will be cache line that is equal to block address divided by number of cache lines. And it's a profit simple and fast. It's a loss high control conflict misism. Requires searching all lines to find a match. Profit no conflict misses losses complex and costly hardware. Third, set associative mapping. It cache is divided into sets and each set include multiple lines. A block maps to a set using set number. Block address divide by more number of sets, and within set any line can be used. Profit balance between speed and flexibility. And mapping types, direct indirect mapping, flexibility slow, low, speed high, hardware cost low. Full associative, flexibility high, speed low, hardware cost is high. Set associative moderate, flexibility speed moderate, hardware cost is moderate. Now explain the working. Now explain the working carry look ahead adder. A carry look ahead adder means CLA. It is a fast binary adder which improves the performance by calculating carry bits in advance, and rather than waiting for them to propagate sequentially as in ripple carry adders. Why use carry look ahead adder? This the in a ripple carry adder, each carry must wait for previous one, and after it will be slow for large bit numbers. CLA speeds up addition by generating carries in parallel using logic formula. For each bit I, like generate gi is equal to ai multiply bi. Carry is generated at this position, and propagate pi is equal to ai plus vi. Carry is propagated through this position. In carry formula using g and p, The carry out for each bit is calculated. C1 is equal to Z0 generate plus P0 multiply carry 0. C2 is equal to G1 plus P1 into C1 and expand using substitution. C2 is equal to G1 plus P1. G1 plus P1 plus G0 into G0 into C0 and add so on. Now next is a sum calculations. After that we will be sum calculation. Once all carry ins are known, Si is equal to Ai, we will be implement Ai and Bi and Ci exclusive or. We will find some calculation and example for which CLA input have given 1011 and B is given 1101. CLA compute go to G3 and P2 G0 to G3 and P0 to P3 and C1 to C4 using logic not a sequential. Then compute some bits S0 to S3. The carry look ahead adder calculates carry bits using logical expression which weights based on the generates and propagate function, and it also results faster addition, especially useful in high speed processor. And last topic is a comparison between risk and syscom. um, First is instruction set. In case risk is reduced instruction set computer. It is small simple fixed length instruction. CISC is a complex instruction set computer. It is a large complex variable length instruction. Execution time in risk, most instructions execute in one clock cycle, but in CISC, instruction may take multiple cycles. Hardware. It is simpler user, more software compiler optimization. It's more complex due to instruction in decoding. Memory access limited. Typically load store architecture. It allows the memory access within many instructions. Pipelining is easier to implement and optimize. It's harder due to instruction complexity. Example ARM, MIP, SPARC and x86, Intel 8086. These all are the instruction set of CISC, and these are the RISC. And this is very important question, you should be learned properly. Thank you. If you like this video, please like and share my channel with your friends for next upcoming videos. Don't be forget to subscribe my channel for next upcoming videos.